Hello, this is Mr. Collier, and today we're going to be looking at some functions and their graphs. Um, this first example, we're given the following function, and we have to write down the domain of f of x. So remember, the domain is basically the list of all possible x values that the function can have. In this case, x could be anything, except it can't be 0. So we can write that as x can be any real number such that x is not equal to 0. With set notation brackets. And we're going to copy and complete the table of values for f of x. Give your answers to correct to two significant figures. So we can type in each one individually here. Right now I can type in a value for this one because it's actually undefined right here. So there is no value for f of x here. I could say undefined, maybe UND, or you can use maybe this symbol here means also undefined. It kind of looks like a 0, so I'm not going to use that one. So we're going to type that into our calculator and use the table feature of the calculator in order to fill out the table. So I'm going to type that in. You'll likely need some brackets first, and then or you could actually, let me do it this way: alpha, then y equals, and I can make a fraction right here. This is only available for the newer operating systems for the TI-84. So we have 3x minus 12 divided by x. And I want my table to go from negative 24 up to 24. So I'm going to go to second function window. That gives me table set. And we're going to start at negative 24. And we're going to go up by ones, I guess. And then I'm going to go to second function table. Okay, so right now we've got the y values are all here as fractions. Okay, so one way to fix that is we can go back to the function and then scroll over to the far right of the function. And we can go to math and click on the to decimal button. That will convert it all to a decimal. If you go back to the table, now all of our y values are as decimals, right? So we're going to get this, see the first y value we need is 3.5. So that's 3.5. Then we're going so here's our table of values. We're going to draw the graph from negative 24 is less than or equal to x is less than or equal to 24. Use a scale of 1 centimeters to represent 4 units on the horizontal axis and 1 centimeter to represent 2 units on the vertical axis. Okay, so we're going to graph this function now. I'm going to plot these points. So I'm going to set up some axes here. So there's my x and my f of x axes. And I'm just going to plot the points now, maybe in red. Oh yeah, we're going to use a scale of, what was the scale? 4 units on the horizontal axis and 2 units on the vertical. So every unit is going to be 4 here. So that's 4, 8, 12, 16, 20, and so forth. On the vertical axis, they ask us to go up by 2, so 2, 4, 6. I'll fill in that later. Okay, so let's plot the points. We have 1, negative 9, so that's 1. And we're going down by 2, so it's 2, 4, 6, 8, negative 9 is right there. And actually, maybe I'll use a different color. There's negative 9. Oops, sorry, that's 1, negative 9, so just let me undo that. Alright. So 1, negative 9 will be like right here, and then down 6, 8, 9, like right there. 2, negative 3 would be right there. 4, 0, so that's the next intercept. Then we have 8, 1.5 would be about there. 12, 1.91. 24, 2.5. Right there. Okay, and then we have the negative values over here. So negative 1, negative 115. So that's way up there. That's 8, 10, 12, 14, 15. So negative 115 is about here. Negative 4, 6 is right there. Negative 12, 4 is right there, and negative 24. So that's 4, 8, 12, 16, 20, 24. 3.5 is right here. So you can see what the kind of the shape of it's going to be. We can also check the shape with our calculator and make sure we're getting the right shape. So I already have the function in the calculator. I can just go to graph right now. Actually, I need to change the window to go from negative 24 to 24. Okay, so I'm at negative 24 to 24. And the y values look like they go from negative 10 to 20. Should be okay. Negative 10 to 20, and let's graph that. So here's what it looks like. You can see it's a curved part right here and a curved part right here. And here at in the middle here is where x equals 0. Remember, that value is undefined. So when it's undefined, we get this asymptote right here. So it's going to look like this, kind of something like that. Oops, kind of twisty. And like this. And we got the asymptote in the middle here. Okay, so that's the graph. And write down the equation of the vertical asymptote. Well, that is right there at basically x equals 0 is the equation of that vertical line. So x equals 0 is the equation of that asymptote. Next question, we're going to sketch the graph of this function from negative 5 to 5. Now if it says sketch, you don't have to draw a nice neat graph like this. We're just going to use our calculator for that. So now I've entered the function into the graphing calculator, and we need to adjust the window to go from negative 5 to 5. So I'm going to go from negative 5 to 5, and then what do we set the y window to? Well, one way to figure that out is you can go to second function graph, and here's your table. Oh, what happened to my table? Actually, I'm going to set the table to go from negative 5 as well. So I'll go to the table, and I'll start off at negative 5, go up by 1s, and then when I go to table, we got the values here. Looks like we're going from about negative 15 to 15 would be some good y values. So I'm going to put that in for my y min, y max, and let's see if that works out. So there you go. It's like a parabola, and we can see it all, and that's the sketch we can do. Alright, so I'm just going to get a little copy of that, paste it over here, and to sketch that, we need to draw in some important bits here. So we've got f of x here, and x, and this is what it looks like. Our range is negative 5 to 5, so we can put that in there as well, like negative 5, 5, so we get some idea of the size of this thing. You can also check out on your table, maybe the y-intercept is 12, so we can probably label that point so we have some indication of the size of the parabola. Okay, in the next example, we're going to use our graphing calculator to graph these two functions and then solve this equation. Well, notice this equation is just the two functions added together, right? So by solving this equation, you're basically finding the intersection of these two things. Okay, one's an exponential, the other's downward facing parabola. There's possibly 2 points of intersection, right? We call POI. So we're going to put that on our calculator and solve. So I've got both functions typed into the calculator right now. So I can graph them maybe and see where they intersect. And they do intersect at 2 points. So I can go to second function trace and calculate the intersect, which is 5. So I'm going to go for this one on the left first. I'll click enter, enter, maybe go close to that point of intersection, and we get We get the first point of intersection. I'm just going to copy and paste that over here. And then we're going to do the same thing to get the other point of intersection. So 5. So I'm going to click enter, and then enter. And then my guess, I'll just move the cursor closer to the other point of intersection. And press enter. And the other intersection is 2, 4. So that one's pretty easy. So 2, 4. And the other one is negative 0.364, comma 0.777. So these are the points of intersection that we got by graphing. So this is a test question. You should draw a little sketch and show the curves on the sketch, and maybe you can label the points of intersection. So in this next example, we're given some real-life data, and we're asked to answer these questions. What are the two variables represented by this graph? So here, you can say, well, let's write it over here. In this example, x is number of years since the initial year, which is 1990. And the y values in this case is number of barrels per day. So number of barrels per day, and it's in thousands. So it's important to remember that when we're answering the questions. Part B, what does the blue curve represent? So the blue curve represents how much oil China has been consuming. Okay, the amount of oil consumption of China. And what does the green curve represent? Is China's oil production. Alright, part D, explain the meaning of the point where the both curves are met. What is the year at that point? So the year at that point is 1992. So basically in 1992, China's oil consumption and production were the same. Alright, so at that point, China went from an oil producer to an oil consumer because they're consuming more oil than they produce, and then they have to import oil and things like that. So before 1992, what happened was, basically China produced more oil than it consumed. And what is the tendency of oil consumption in China? The tendency is, you say that China's oil consumption So China's oil consumption is increasing. Okay, now you could maybe type this data into a calculator. It looks like it's kind of linear. So maybe we can say we could probably do a regression line in GeoGebra or something like that. But it looks like it's increasing linearly.